Okay, good morning. Today we are going to start our new chapter, structure of atom. Oh my God, what happened? What is this? Okay, structure of atom. Okay. Okay. First of all, see, they have Dalton. We will start with Dalton. Okay, the Dalton explained some properties of matter. Okay, first of all, Dalton said that everything, every thing which is made up of atoms. Okay, every matters have is made of the very smallest particle called atom. Okay, so Dalton gave some atomic theory which we are known as Dalton's postulates of atomic theory. Okay, according to the Dalton's atomic theory, okay, atoms is a hard sphere. Okay? According to the Dalton's theory, atom is a hard sphere, okay, which is indivisible. Means according to that Dalton's, atoms cannot be further divided. Yes. Okay, which after sometimes it was failed. Okay, after the discovery of electrons, protons, and neutrons. Okay, it was failed that atom was indivisible. But that time Dalton gave his theory that atoms are indivisible. Okay, everything is made up of atoms, and what as every one kind of element, okay, is made up of a one kind of atom. Means all atoms of one element are alike. Okay, which is different from the other element. Correct. For example, the atoms of gold. Okay, so gold has all the gold atoms, which is completely different from other element atom like sodium, silver. Okay, and all combination of elements. Okay, and all combination atoms take part there in their combination. Okay, so in any reactions, what is the species which are taking part? It is the atoms. Okay, but after the discovery of electrons, okay, his theory was like failed, and he said that every element, every same element has a same atom. Okay, as all atoms are alike in a kind of element. It was also again a failure. How? By the discovery of isotopes. Okay, after the discovery of isotopes, this theory was also failed. Okay, like for example, hydrogen has three isotopes, H11, 12, and 13, and all isotopes of hydrogen atom are different. Okay, but Dalton said that every atom of an element are alike. Understand? Which was again not correct. And he also said that the atoms of one element is different from the atoms of other element. Again, this was proved wrong by the discovery of isobars. Okay, so we'll discuss all these isotopes and isobars. Okay, first let's see the discovery of electrons. Okay, first we will see discovery of electrons. this one experiment was done by J. Thomson. Okay. J. Thomson did an experiment known as cathode ray experiment. Okay, cathode ray experiment. Here, what he have done, he had taken a one discharge tube like this. Okay, suppose this is a discharge tube. He has taken two electrodes. Okay, one is a cathode and other one is anode. Okay, cathode is the negative electrode, right? This is what? This is cathode, and this one was anode. Okay, cathode was negative electrode and anode was positive electrode. So this was the discharge tube, and he gave a very high voltage here. Okay. And here was something to like this to vacuum the pump. Okay, to vacuum. Okay, this was is all its setup. Okay, what by Thomson. Okay. What happened here? See, and okay, so our vacuum is to to make the pressure very low. Okay, so this is air at very low pressure. Okay, air at low pressure. Okay, so this was a discharge. It's also known as a cathode ray discharge tube. Okay, here what happens that he found, yeah, and also here he put some fluorescent zinc sulfide coating. Okay, this is a zinc sulfide coating. This one is a zinc sulfide coating. Okay, why he put zinc sulfide coating near anode? Okay, so that if any rays fall on that coating, it starts glowing. Okay, it is known as a fluorescent coating. It starts fluorescence. So what happened when a high potential is given there? Okay, when a high potential was given, it okay. And one more thing, this anode rays was perforated. Perforated means what? Like sorry, it has holes in between. Okay, it has holes in between. Understand? So when the high potential is given, what happened? The this screen, okay, this screen starts glowing. Okay, after giving high pressure, the screen near the anode starts glowing. Okay, it means what? It means he concluded that there must be something, some rays, okay, which are coming from cathode to anode. Okay, and since the cathode is a negative electrode, electrode is what of metal. Okay, so what happens that anode means positive charged. Okay, they attract that negative particles towards itself. Okay, so after when the high give voltage was given, okay, what happens? The electrons from the cathode, okay, starts coming out in a ray, and it goes towards the anode, okay, positive charged rod, and strike to that say, screen, and screen starts glowing. Okay, then what he concluded by this experiment that there must be some negatively charged particles, okay, which on giving potential high voltage, okay, starts coming out. Since the rays are invisible, so he put that zinc sulfide screen, that fluorescent screen. So whenever that rays fall on that, it starts glowing. Okay, So this was a simple experiment done by Thomson. Okay. With this, he said that there are some negatively charged particles present inside the atom. Okay, which on voltage coming out from the cathode to anode. Okay, and this is the negative particles which he named electrons. Thus, it was discovered. He discovered the electrons. Okay, this was a discovery of electrons. Now after that, okay, after that Goldstein, okay, he did another experiment. What he did, he performed the experiment in just a reverse case. Okay, he put that he has taken this type of discharge tube. Okay, okay, again taken this type of discharge tube, one cathode and anode. Okay, same setup. But what was the difference here? Okay, at this is something to vacuum pump. This was now this time. This is anode. Okay, and this is cathode. Understand? Now he put again perforated. Now it was the perforated anode. Okay, in cathode rays. But in anode rays, perforated anode. Understand? This time, sorry. This is cathode. Negative electrode is cathode. Okay. Now he has taken the perforated cathode electrode. Okay. Again, same thing. He put zinc sulfide here as a screen of zinc sulfide. Okay. What he found again after when he changed the electrodes. Okay, means he put a zinc sulfide coating behind the cathode this time. Okay, and again he gave a potential, and he found that again this screen starts glowing. Okay, there is a fluorescence in the screen. So now this time, which rays were coming out? This was anode rays. Okay, because this time rays was coming from anode to cathode. Okay, anode to cathode. Okay, since cathode was negative electrode, so he named it like a positive charge. Some positive charge particles are coming from anode to cathode. Okay, what happened in cathode ray? In cathode ray, the electrons are coming. Okay, from cathode to anode. Understand? Anode was positively charged particles. Now in Goldstein experiment, he put zinc sulfide screen behind the cathode. So the rays was coming from anode to cathode. So he named it anode ray experiment. Okay, and this was the discovery of proton. Okay, discovery of proton means he said that there are some positive charged particles also present inside the atom, which are attracted towards the negative electrode. Okay. But see, but there was one very interesting thing that he found. Okay, that in during the cathode ray experiment, okay, they used to change the electrodes. Sorry, they used to change the metal electrodes, मतलब metals. Okay, and the air inside it. There are some air. Okay, so by changing the air, this is careful. This is very important. by in cathode ray experiment. In cathode ray experiment, by changing the metal electrodes, the type of metal electrodes, okay, or by changing the pressure, okay. He measured the charge by mass ratio, okay. Charge by mass ratio is known as what he measured? Charge by mass ratio, that is E by M. Okay. So what he found that E by M is same, okay, in all type of gas, in all type of a metal electrode. In the case of cathode ray, okay, in cathode ray experiment, he found that all types of the charge upon mass ratio is same for every kind of gases and electrodes. Okay, means what? Charge upon mass ratio is independent on what? Gases and metal electrodes. Okay, the charge upon mass ratio, okay, of an electron is not changing, not changing. Okay, electron, this charge of electron on by mass of electron is same everywhere. Okay, but charge upon mass ratio of proton, okay, in anode ray experiment was changed with the changing in gases. Understand? Okay, means charge upon mass ratio of a proton, okay, changes with change in gas. Okay. So what can you guess why this happened in cathode ray experiment? Okay. In cathode ray experiment, when the rays are coming from cathode to anode, okay, charge upon mass ratio of electron, because electron was coming is fixed. Okay, it means what? Electrons are coming from the electrodes. Okay, doesn't depend upon the type of gas it interact. Okay, but what happens in anode ray experiment? Okay, charge upon mass ratio of anode of proton changes with the change in gas. Okay, means what? That proton is might be coming from the gas particle. Okay, that's what. So electron was discovered by Thomson. Then Goldstein discovered the protons. Okay. After that, after that, protons and electrons. Okay. Rutherford. After these two experiments, okay, Rutherford performed an experiment. Okay. Rutherford, that is known as alpha ray scattering experiment. Okay. Alpha rays scattering experiment. Okay. Actually, Rutherford was the student of Thomson. Okay. Yeah, one thing I forget to tell you. Before that, first Thomson discovered the electron. Okay. And he also gave a very important model. Okay. After discovering the electron. Okay. J.J. Thomson, after discovering the electron, okay, Thomson has given okay, a model, atomic model, okay, given an atomic model, which he named as a plum pudding model. Okay, the name is plum pudding model. Okay, also known as a watermelon model. Okay, what he said, according to Thomson, okay, that the atoms are a sphere of positive particles. Okay, atoms are what? Atoms are sphere of positively charged particles. Okay, atoms are sphere of positive charged particles. Okay, and electrons are embedded in between them. Okay, means this is all the okay. Means I can say that suppose this is a atom, okay, and protons, positive charge particles are scattered everywhere, okay, and in that electrons are embedded, just as just as plum in the pudding. You know pudding we used to eat, okay, pudding, kheer. Yeah. Okay. So we put dry fruits over the pudding. Okay, which is which we embedded in between the pudding. So suppose the pudding is a sphere of positive charge particle. Okay, and the dry fruits which we used to put over it, okay, is like electrons. Okay, so atoms are sphere. Okay, atoms are sphere with positive charge particles, and electrons are embedded in between them. Okay, just as you can say other example of watermelon. Watermelon, the red part are supposed to be red part. Watermelon has a red part inside. The red parts are like protons, and that small black seeds are between. It's like electrons. Okay, so he gave plum pudding model or watermelon model. Okay, watermelon model. Okay, atoms are sphere of positive charge particles. Okay, and electrons are what? Embedded. Okay, embedded in between them. Plum pudding model or watermelon model was given by whom? Thomson. Okay.
And this plum pudding model he gave before this discovery of this
proton.
proton.
First, Thomson discovered electrons. After the discovery of electrons, he gave plum pudding model. Okay, because he was not knowing anything about proton, but he knew that atom was neutral. Okay, means atom is electrically neutral. So he thought that if electrons are discovered, there must be something positive charge particles which is equal in number of electrons. That's why the atoms are electrically neutral. Understand? So what he think, he was not knowing about protons. Thomson discovered only electrons. Okay? After his discovery, he has given this model. Okay? And he thought that he said that since atoms are electrically neutral, it has no charge. So electrons are discovered, means there are some negative particles. So there must be some equal number of positive particles. And positive particles are maybe scattered everywhere. And in that, electrons are embedded in between them. Okay, is that clear? After that, Goldstein discovered protons. Okay, and after these two experiments, Rutherford. After these two experiments, okay, Rutherford did an experiment known as alpha ray scattering experiment. Okay. Actually, Rutherford was the student of Thomson. Okay. So what he was expecting in his experiment, that protons are everywhere, because as that Thomson said na, that there are some positive particles, protons, which are spread everywhere, and electrons are embedded in between them. Okay. On the basis of this, he performed an experiment ठीक है. Then where he used an radioactive element. ठीक है. Where he used a radioactive element which he kept inside the lead box. Because radioactive element is what? Which has a very unstable nucleus and degenerate itself. ठीक है. Giving what? Alpha rays, beta rays and gamma rays. ठीक है. Here he has to use what? Alpha rays. Alpha rays are, what are alpha rays? Alpha rays are positive charge rays. ठीक है. Alpha rays has a positive charge. Means alpha rays has a charge of 2. ठीक है. Has a positive charge 2 and mass of 4. Understand?
Yes.
It's equivalent to the nucleus of helium. Right?
Yes.
As helium has 2 protons with 2 positive charge and 4 mass. Understand? And you were asking about that, na? That you were asking that the alpha rays are helium or what? You were asking? Oh, I don't know. So actually, alpha rays are those rays which has a charge of +2, okay, and a mass of 4, okay. So very means heavy rays, okay, +2 charge, heavy rays. So he used this rays for his experiment, okay. So these rays are coming from the radioactive elements, okay. Radioactive elements, why? Because it degenerate itself, okay, when kept. So these rays are coming out like this. Okay. So first he take polarization of the light rays. Okay. After that polarization, all rays start coming in same direction. Okay. Then what he has taken? He has taken that type of a sheet, fluorescent sheet. Okay.
Okay.
Or you can say this is a photographic plate. Photographic plate. Okay. And a one gold foil, very thin gold foil. Okay. What will happen when these rays fall on the gold foil? Okay. Because why he's taken gold foil, a very thin gold foil, because of the want to test with the atoms. Okay. So what he was expecting, according to the Thomson, what was he expecting? He was expecting that when these alpha rays, means positive rays, will fall on the atom, and since atom has protons everywhere, so all the rays will scattered, right? Right now, it cannot go straight. Okay. All the rays will scattered because protons and protons.
Yes.
Okay. So they will deflect. Okay. And all the rays will scattered. But actually, this doesn't happen. Actually, the result was just opposite of his expectation. Okay. He was expecting, on the basis of Thomson theory, that when alpha rays will, okay, will pass the atom, and since atoms have protons everywhere, so it will scatter. But no, most of the rays, okay, go straight. Few of them scattered. Okay. I can show you like this. Okay. Most of the rays go straight. Okay. Few of them scattered to a slight angle. Okay. And very few of them return back. Okay. Go back. Like 1 in 20,000.
Okay.
So with this experiment, what Rutherford concluded? That atom has a large empty space. Understand? Atoms has a large empty space, okay, which allowed the rays to pass through it linearly without any deflection. Understand? And some are deflected. It means that all the positive charged particles are inside a very small part nucleus. Okay? All the positive charged particles are contained inside some small part nucleus. Okay? We call it nucleus. Okay? And electrons are revolving on the in the in the shell. Okay? What he found that atoms are like they have a large empty space, okay, and all the positive charged particles are inside, are contained into the in the nucleus, okay, and electrons are revolving around the shell, okay, around the atom. Okay, so this way he discovered what the Rutherford discovered. Rutherford discovered the nucleus. Okay, Rutherford discovered nucleus. Okay. So electron was discovered by Thomson, proton was discovered by Goldstein, and nucleus was discovered by Rutherford. Okay, by his experiment, the gold foil experiment or alpha ray scattering experiment. Okay, where he found that all the positive particles must be inside a nucleus. Okay, and it's not scattered everywhere. Okay, after all this discovery, okay, and he found that besides, okay, till now electrons and protons are discovered, okay, and it was also discovered that protons are inside the nucleus, but they also observed, they also found that besides electrons and protons there must be some other particle also, okay, there must be some other particle because of the mass of the atom, okay, is something, means when they found the mass, okay, it was not equivalent to the electron and proton, so there must be something else, okay, which is giving the mass, okay. And after that, Chadwick, okay, James Chadwick, James Chadwick, okay, he discovered neutron. Understand? So James Chadwick discovered the neutron. Now the atoms, all subatomic particles are now discovered. Okay, these are known as the subatomic particles: electrons, protons, and neutrons. Okay, but Rutherford experiment, okay, there was some drawback in the Rutherford experiment. Electrons in Rutherford model are negative charge particles, right, which are moving in orbital. Okay. What Rutherford said that protons are inside the nucleus and electrons are moving, okay, in a circular motion. Okay. Okay. Electrons are moving continuously in a circular motion. Okay. And according to Maxwell, what he said that when accelerated charge particles, okay, when charge particles are accelerated, because it is, if it is moving, it means what, it is accelerated, okay, so accelerated charged particles would emit some electromagnetic radiation, okay, which is equivalent energy possessed by radiation associated with the electronic motion, okay, something understanding. Electrons, according to Rutherford, okay, electrons are moving,
Yes.
okay, in a circular motion in its orbit, ठीक है. And Maxwell is a very known physicist. ठीक है. So, तो he, according to him, ठीक है, any charged moving particle is accelerated, ठीक है, and emit electromagnetic radiation, ठीक है, which is equivalent to the energy associated with the electronic motion, ठीक है. Means what? If electrons are moving in a circular motion, it must emit some electromagnetic radiation, ठीक है, and after some time it will fall inside the nucleus. Understand? If it is, suppose it is moving like this, okay, it will fall inside the moving and it will fall inside the nucleus. Come inside the nucleus. So thus electron orbiting about the nucleus would follow a spiral path to the nucleus. Okay, and the atom become unstable. Understand? So what was the drawback of the Rutherford? Rutherford could not explain the stability of the atom. Okay, if he said if electrons are moving in circular motion, okay, after losing, because it in circular motion in its charged particles, it is losing electromagnetic radiation, okay, and after that, after some time, it will fall inside the nucleus, okay, and it will become unstable. So yeah, the side on. Then there was some drawback of Rutherford experiment. Okay. First, he could not explain the stability of the atoms. Okay, means what? Electrons revolving in an atom, okay, would fall inside the nucleus and will become unstable. Second, he does not describe the distribution of electrons around the nucleus. Nucleus, okay, and their energies. Understand? He could not explain. He could not. He said he just only explained. Just only said that electrons are revolving around the orbit. Okay, in the orbit, but he could not explain its exact position. Okay, how the electrons will distributed in the shell and the energies. Okay, so these were the drawbacks of the Rutherford. We have seen all the three major experiments, okay, and their drawbacks as well, right? So Rutherford experiment, he could perform the experiment, he explained about the nucleus, but he could not explain the stability of the atom and he could not explain the arrangement of the electrons. Okay, so here we have seen that we concluded that atoms have okay, three what subatomic particles, right? Name it.
Electron, proton,
and neutrons. Okay. Neutrons. Okay. After this, all the subatomic particles are not discovered. Electrons, protons, and neutrons. Okay. And protons and neutrons are where are found inside the nucleus. Okay. And they altogether known as nucleons. Okay. Both if we Nucleons means what? Nucleons means the protons and neutrons. Okay, and electrons are revolving around the in the orbit. Okay, around the atom. Now there are three terms related with these atomic particles. Okay, these are atomic number. Okay, atomic number is what? You know atomic number, atomic weight. Okay, atomic number is the number of electrons, and number of electrons are always equal to the number of protons. And atomic weight is the total number of proton and neutrons. Understand? Okay. Now we'll see some other terms. Isotopes. Okay. What are isotopes? Isotopes are the elements, okay, have same atomic number but different mass number. Okay. Those elements which have same atomic number but different mass number. Example? Hmm? No. Isotopes. Isotopes are those elements which have same atomic number but different mass number. Hmm? Okay. Element having same atomic number but different mass number. Atomic number, just we know, we have seen atomic number is the number of electrons, yeah, protons. Okay. Mass number is the number of total number of protons and neutrons. Yeah. So, for example, we'll see isotopes of hydrogen. Okay. 1, 1, 1, 2, 1, 3. Okay. What you find here, all hydrogen, all 3H has same atomic number 1, 1, 1, but their mass number are different. Understand? They have same atomic number but different mass number. For example, chlorine 17, 17. Atomic number same. It's 35, it's a 37. Okay? Different mass number. So what is that? Why this happens? All atomic numbers are same. Means all of these hydrogen have same number of electrons and same number of protons. But mass number are different means that the difference is in their neutrons. Okay? Yes?
Only how many elements have isotopes and how many elements are isotopes?
Yeah, also little elements like carbon. Okay. Carbon has isotopes C6, 12, C6, 13, and C6, 14. Carbon has three isotopes. Okay. Few elements have isotopes. Not every element show isotopes. Okay. So carbon has three isotopes C6, 12, 13, and 14. Okay. And this one is known, this C14 is the radioactive carbon.
Yeah.
Okay. So all of them have same atomic number with same atom, same electrons, same number of protons, but different is in their number of neutrons. Okay. This carbon has 6 electrons, 6 protons, and 6 neutrons. Okay. This carbon has 6 electrons, 6 protons, and 7 neutrons. Okay. And this has 6 electrons, 6 protons, and 8 neutrons. Okay. 8 plus 6 is 14. This is the difference. Okay. Understand? Now it is isobar. Okay. isobar. This is what atoms of different elements having the same mass number but different atomic numbers. Okay. Here the condition is reversed. Are called isobars. Okay. The atoms of different elements having same mass number. Here the mass number is same and atomic numbers are different.
Okay.
Okay. Since atomic number changes means what? Atoms are elements are changes. Okay. Atoms of different elements. Okay. Mass number changes means elements changes. So atoms of different elements having same mass number but different atomic number. For example, C614 and N714. Okay.
Neutron number is same.
Yeah. What happens here? They have a different atomic number. Carbon 6, nitrogen 7, but same number of same mass number.
Okay.
Okay. This type of elements are known as isobars.
Yeah.
Okay. And okay, we'll calculate this. Okay. Nothing is same in those in this. Only mass number is same. Okay. Electrons, protons, and neutrons all are different. Next is isotones. Of atoms of different elements having same number of neutrons. Their nuclei. Okay. I should know isotopes, isobars, and now isotones. Okay. It is what atoms of different elements. Okay. Having same number of neutrons in their nuclei. Here the neutrons are same. Okay. For example, we'll see boron. Okay. Boron 5 and 11. Carbon 6 and 12. Okay. What will be the atomic number here? What is atomic number of boron? Atomic number. Okay. Boron is carbon 6. Okay. Number of protons 5. Same as atomic number, na? Number of proton here 6. Now neutron
6.
6. Neutron, the neutron are same. Okay. This is the isotones. We have seen isotopes, isobars, and isotones. Okay. Now there is after that, after all this, because after the limitation, after the failure of drawback, okay. Now Bohr's, Neil Bohr's, he gave his atomic model. Okay. Neil Bohr's gave his atomic model. But I think time is up now. है ना? His model is a little big, it will take some time. Mhm. But what we have learned today,
We have proton.
discovery of electrons, okay, by Thomson, the cathode ray experiment tube, okay. Then
The
protons by Goldstein, then
discovery of nucleus.
mm,
So,
discovery of nucleus by Rutherford, okay. Rutherford then had an experiment with alpha rays, okay, and gold foil. Then he discovered the nucleus, okay, but there were some drawbacks, okay. After that, neutrons by James Chadwick, okay. Then we have seen three terms: isotopes, isobars, and isotones. Okay, all that clear? Tomorrow we will see Neil Bohr's model, okay, and his failure. And after that, all the theories. Okay, actually, this time till now, okay, up till Bohr, it was considered as electron is particle nature. But after that, some theories came which prove that electrons have dual nature, also wave nature and particle nature. Okay, so tomorrow we will do this.